your understanding of what you just did to help you set up the problem. Mihaela said absolutely correctly that what the variable is, what the thing is that determines the size of the box is the width of the cutout corners. So here's our piece of paper. What size is that paper? That 8.5 by 11? So here's our piece of paper that's 8.5 by 11. And we are going to cut out corners, square corners, that are X by X. And our job is to make the box that will hold the most. What do we call the amount something will hold in geometry? Volume. What? Volume. So we want to maximize the volume of the box. That's what we want to do. We want all of us have the same size piece of paper. We want to find the size of the corners that will create the biggest box possible. You in agreement with that? Now, what's the formula for the volume of a rectangular solid, the volume of a box? Length times width times height. Now, be careful. Remember, this, I guess, I'm going to make these look like they're more dimensionally appropriate. The length of this paper was 11, but the length of the box isn't 11. Because, remember, you cut these corners out and you folded up these flaps. Can you visualize what you did? Now, this would be the length of the box, wouldn't it? And how long is that?
Don't know.
Well, we don't know, but we can express it.
11 minus 2x.
11 minus 2x. Because the whole paper was 11, but you chopped off an x and an x here, so this is 11 minus 2x. That's our length. What's our width? This would be our width here, because remember you folded these flaps up. So this would be our width. What would that be? 8.5 minus 2x?
So when we do these problems, are we always assuming that x's are symmetrical or the same? Or x's are always equal to each other?
They have to be.
Okay.
Otherwise you won't have a box. You'll have some weird shaped thing.
Okay.
Right? Now what about the height of the box? Think about when you folded up the flaps of your box. Here's the piece of paper. You folded up the flaps. What was the height? What's the height of that box when you fold up those flaps? How tall is it? X. Now we're getting ready to go to our calculator because this is the volume. This is the equation for the volume. And what do I want to do? I want to find the maximum. So I'll use my calculator. But before I start pressing buttons, I want to talk about domain. What is the domain of this function? Now, if you were to find this equation lying in the parking lot out of context, the domain would be all real numbers. Because why? There's no radical and there's no denominator. However, it's in context. So tell me about x. Tell me how big, how small x can be. It can't be anything. What's its lower limit? 0. X has to be bigger than 0. Would you agree with that? If x, well certainly x can't be negative. And if x were 0, we would just have our flat piece of paper, no box. So it's got to be bigger than 0. Okay. What's the upper limit for x?
8.5, 4.
4 1/4. Beautiful, Blake. Why do you say 4 1/4?
Because it has to be less than half of 8.5.
Exactly. So Nick, you were right. You were zeroing in on the small dimension. You said, well, it's got to be less than 8 1/2. You're right, but remember, we're taking a chunk off each side of that 8 1/2. So it would have to be half of 8 1/2. You're going to take a chunk off each side of that. So this is my domain, which means when I go to my calculator, X min will be 0 and X max will be 4.25. All right, so here we go. Let's see if we can find the maximum volume of the box. You can put this equation in just like it is. Just make sure you put parentheses. Now, when you graph, keep in mind, X we've already talked about. Y represents the volume, right? So what's Y min? What's the minimum volume? 0. And Y max is what we're trying to figure out, so just guess a number. If something like this happens, what does that tell you? You get something that looks like that. You have to make your Y max higher. You need to see the top of a hill. So keep messing with it until you see the top of a hill. Now, it won't be a parabola. This isn't quadratic. But you should see the top of a hill. Everybody seeing it? Everybody getting the top of the hill? Okay, how do we find the maximum point? You know this already. We took a test over it. How do we find the maximum point? This is a participation sport. Second count. And as always, you're going to get an ordered pair. So let's talk about, first of all, I got 1.585, comma, 66.148. Anybody else get that?
Yeah.
All right, let's talk about then what those two numbers represent. What does the 1.585 mean or stand for?
How big X is?
How big X is, which is how big the corners are that you cut out. So if you wanted to make the biggest box possible, you have your little ruler out and you would measure X's that were 1.585 inches. That's what you cut out. What's the 66 number represent? That is the maximum volume. That is the maximum volume. So if the question was, find the maximum volume, 66.148 cubic inches is your maximum volume. Okay? Does anybody have a question about that? Robert?
What? So like 1.585 would be measured in like
Inches.
inches?
Yeah,
or-
because our original piece of paper was 8.5 by 11 inches. Yep. Bailey?
I don't understand why
Grace, what's on that iPad? It's driving me crazy.
it's black and blue.
Okay.
It down.
Bailey?
Why the 66.13 is the answer, but not the 1.5?
Because the question was find the maximum volume. And volume is y in my equation. And this is the y coordinate of the ordered pair. Now, if the question had been, how big of corners should you cut out? Then the answer would be 1.585, because x is the corners that you cut out. Alright, got it? Okay, let's look in your book. On page 160. Couple things I want to point out. At the top of the page in the quick review are a bunch of formulas that you need to know. So if you have forgotten, actually you don't need to know all of them. You need to know the area of a triangle, the area of a trapezoid, the volume of a cylinder, volume of a cone, volume of a sphere, surface area of a sphere, and surface area of a right circular cylinder.
You said those were
You need to know 1 through 7.
Oh.
The other ones we're going to get later in the book, so that's okay. 8 you probably already know anyway. Okay, you need to know those. Alright, now your homework tonight looks like a lot, but I want to show you kind of what's going on. So I'm going to pick number 15. This is one of your homework problems, but I want to show you kind of what you're doing. For number 15, here is the task. The height of a right circular cylinder equals its diameter. Okay, so everybody knows what a cylinder is, right? There's a cylinder. And it says the height equals the diameter. Write the volume of the cylinder as a function of its radius. Okay, well the formula for the volume of a cylinder is pi r squared h. That's one of the ones in the list there that you need to know if you don't know it already. You learned all those in geometry. Okay. Now, tell me about the radius. If I call this r, which I can do,
it's half the height.
d would be 2r. Would you agree with me?
Yeah.
Now it says the height is the same as the diameter. So if the diameter is 2r, what's the height? 2r. So my formula says I take pi times the radius squared times the height.
Let's see.
Would you agree with that?
Yeah.
And if I simplify that then, I get what? 2 pi r cubed?
Yep.
And that is your answer.
Is it a function?
Yeah. Yep, that would be a function. This is like y, and that's like x. So it's really no different than like y equals 3x cubed. It would just be a variation of the cubing function. Yeah. Now, that wasn't so hard, was it? That wasn't hard at all. Let's pick another one. 16. One leg of a right triangle. Now remember, when we talk about the legs of a right triangle, we are talking about the ones that aren't the hypotenuse. So one leg of a right triangle is twice as long as the other. Does that setup look okay? Write the length of the hypotenuse as a function of the length of the shorter leg. Okay, you're letting the language bother you, and it shouldn't. Would you agree this is the shorter leg?
Yes.
Okay, this is the longer leg.
Yeah.
Now how am I going to find my hypotenuse? What do I know about the hypotenuse of a right triangle?
A a squared plus b squared equals c
I'll
squared.
call that c for a minute, and x squared plus 2x squared would equal c squared, agreed?
Mhm.
All right, let's solve for c. What do I got here? X squared plus 4x squared equals c squared. So 5x squared equals c squared, you with me? So what's c? What's the hypotenuse?
Square root of 5.
The square root of 5x squared, which is x root 5. So the length of your hypotenuse is x root 5. Done. That wasn't so bad. Pick another one. We're sticking 1 through 20. 18. A square is inscribed in a circle. All right, do you understand what that means? A square is inscribed in a circle? Is that okay? Write the area of the square as a function of the radius of the circle. So there is a radius. And I need the area of the square. How do you find the area of the square?
Base times height.
Side squared. So here's the side. Now, this is a great formula, but it's in terms of a side. You need to somehow get that formula in terms of R. So do you see any relationship between R and S?
They're the same way.
R and S are not the same length, no.
R is
Amy?
half the S.
What?
R half.
No. Let's talk about this for a second. Let me draw in another radius. Oops. Pretend that's another radius. Anybody have any idea what kind of angle that is right there?
Right angle.
That's a right angle. The diagonals of a rhombus, which a square is a rhombus, are perpendicular. So we've got a right angle right there.
So that's the hypotenuse.
This is the hypotenuse. So can we say r squared plus r squared equals s squared?
Yes.
And 2r squared equals s squared? So what does s equal?
2r squared.
R root 2.
R root 2. Now I'm really going to give you a blast from the past. These two sides are congruent. That's a right triangle. This is a 45, 45, 90 triangle. Do you remember learning that the hypotenuse is root 2 times the shorter side?
Yes.
So that would have been another way you could have figured this out. If this is R and this is R, this is automatically going to be R root 2 because it's a 45, 45, 90 triangle. If what I just said sounds like, I don't know, Taiwanese to you, then forget it and just do your Pythagorean theorem. So what's the area of the square? It's s squared, which will be r root 2 squared, which will be 2r squared. That is the area of the square. All right, we'll do one more. Pick another one.
20.
20. An isosceles triangle has its base along the x-axis with one base vertex at the origin and its vertex, oh gosh, this sounds complicated. Let's see. Draw it as I go. Okay. One vertex is at the origin. And vertex is up here in the first quadrant. Okay. So here's my isosceles triangle. area of the triangle. What's the formula for the area of a triangle?
Base times height times height.
1/2 base times height. Alright, now let's talk about a couple things here, just getting this thing started. How did I know how to draw y equals 6 minus x squared? I mean, I just slapped that up there almost carelessly. How did I know that?
It's x squared.
Okay, I know what x squared looks like. What does putting a negative in front of it do? Turns it upside down. And then what does adding 6 do to it? Moves it up 6. So that equation is negative x squared plus 6. I know that negative x squared looks like this, and then pick it up 6. So that's how I knew that picture, right? Okay. Now it says that the vertex of the isosceles triangle is on that parabola. And one base vertex is at the origin, and the other one's someplace. Okay? Now, this would be the height, wouldn't it? Wouldn't that be the height of the, okay. What are coordinates of this point right here? How far over did I go?
Halfway.
3.
Oh, I didn't go 3, no.
1.5.
I went over half of what? B. So that's half of B. Okay. How far up did I go?
Say, about 5.
Well, I can't say about 5. I mean, it's something in there, something less than 6, right? But didn't I go up whatever the y is? That's 6 minus x squared, isn't it? Isn't that y coordinate? Think of this as the point x comma y. And the x coordinate is half of b. And the y coordinate is whatever this is, right? Now tell me about this x coordinate. You said that x coordinate was 1/2 b, right? So what's that y coordinate going to be? If the x coordinate is half of b, what will the y coordinate be? 6 minus, oh come on. Okay, x
1/2
is 1/2 b, yes. So y will be 6 minus 1/4 b squared. You guys, we gotta think a little bit now. These aren't all gonna be just so simple, we gotta think. So we know that the coordinates of this point, let's start over again. We know that the coordinates of this point right here are x comma y. Okay? So this distance right here is y, up y. But my x, you already told me, my x is half of b, it's halfway the base. So my x coordinate is half of b. My y coordinate is determined by this equation. So my y coordinate will be 6 minus 1/2 b squared, or 1/4 b squared. So what's my area? 1/2 the base times the height. Now you're thinking to yourself, I could never do that by myself. Yes, you'll be able to. You have to practice, you have to think. So what is that when I multiply it all together? 1/2 times b times 6 is 3b. 1/2 b times 1/4 b squared is 1/8 b cubed. And there you go. In your packet, there's something I want you to take a quick look at. Then I'll shut up for the day. There is a sheet called, oh, there's no wrong packet. It's typed. Says Precal A 1.7 notes and practice. We're going to do these tomorrow. But I want to call your attention to the thing at the very top of the page. This is actually a little note that's in the teacher edition of our textbook. And I just want you to read it. Because we're not very good at this. The Google generation is not very good at this. Somebody summarize it. What's it saying?
You're gonna miss problems every once in a while, like restart.
Problem solving means restarting a lot of times. Yeah, and maybe restarting more than once. Right? You might try something and it doesn't work or you get stuck, so what do you have to do? Go back and try it again. What are we not going to do? Give up and say, oh, my teacher will do it for me tomorrow. You're going to keep trying. I mean, within a reasonable amount of time. I don't expect you to spend 3 hours. But keep trying. All right? Because that's what problem solving is. Okay? All right. Well, we'll do this sheet tomorrow if that's a good practice on it. Go tomorrow. You've got an assignment. And I want you to do a box problem for me in your homework tonight. So we're going to redo the box problem, and this time let's use a piece of paper that is 20 by 18. So I want you to find the maximum volume of a box that's 20 by 18. Now you should be able to do that. The only difference in the whole setup is going to be when you write your parentheses, you're not using 8.5 and 11, you're using 18 and 20, right? Okay? So you're doing the 20 problems in the homework, of which I already done 4 of them. And then you're going to do the box problem. All right? Everybody okay? Would you make sure all your scratch paper, your